All right, problem 8.3. They mix things up a little bit, doing inch, pounds, and seconds. Easy, part's origin location is indicated in red, so bottom center of our spheroid. All sketches are fully defined. Lines, circles, center lines, arcs, revolves, sweeps, fillets, and chamfers. Extend the sweep into the sphere. So when you're dealing with curvature, usually you want to overrun the geometry a bit so that it makes a full overlap. So let's start with the revolve, and we'll get our geometry going with a vertical, and not going to assume this one is tangent, so let's go with a 3-point arc, and we'll drag it out. We do know that it, at least up to that point, that it's going to be coincident to the center line, and then the outside looks like we have to back calculate. All right, so let's take a look at our numbers again. Diameter of 1.4 inches, radius of 2.5, 3.05 to the center. Okay, so we're not given an actual radius, so I can X out of that. Usually when I put dimensions in like that I don't end up using, I will switch them to driven just so that I have for reference kind of a reality check. Does that make sense? So 3.05. It grew quite a bit. What do we have on? Oh, we do have a radius. All right, so not getting rid of that was kind of handy. We'll just go back into the select and switch it back to driven and find 3.95 in the bottom. So 3.95. Okay, that looks better. All right, we're going to go ahead into the features and revolve. Make that the axis of revolution. Go ahead and accept it. All right, going back into the front plane, we need a sketch, and we'll start thinking on the top. We'll select the midpoint, make that vertical to the origin, and then when I add the overall 10.3, we have a pretty good starting point. And then we go to the tangent arc, and that transitions into a line. Okay, so we know that that's going to, at the very least, be coincident to the silhouette edge of our sphere. And so the silhouette edge, let's just review that real quick, is where the front plane passes through, there will be a solution on this side and a solution on this side that can be coincident. So we want one of those. And we'll go into the radius of 2.5. And our angle then, let's go ahead and complete the mirror. And then our angle becomes 60 degrees. All right, so what am I missing? Oh, the center points between the arcs is 3.2. All right, so that gets us to fully defined. Based on the geometry, the interpretation, since that's an overall dimension, the circle is going to lie underneath. So let's go ahead and accept the sketch. And we're looking at the right plane to draw our circle. and it is given a dimension of 1.4. And then we see what we get. Let's see if that one goes coincident. We could possibly use that. All right, so if there's any issue, I try to generate enough geometry first. All right, so we'll see where this this lands as it completes this. So we'll go into the swept boss base. We pick the profile. We pick the sweep. We go bidirectional. And what we're interested in seeing is, yeah, it terminates at that point because we're at the interior. If we were on center line, then there would be a angle, a gap on this side that doesn't quite complete. So whenever you're dealing with curvatures, you're going to observe that that location and make sure that it actually connects. And if the circle was on the other side, then pretty much it would touch at a point and nothing else would connect. All right, so the last is to pick our fillets. And the fillets were generated was a radius of 1/2 inch. All right, so it finds the curvature. We have something that looks pretty good. Let's go ahead and save it. P8-3. And our volume then, 269 cubic inches. So we're in to evaluate mass properties and 269.03. All right, let's go on into 8.4. We have another clip looking thing. So inch, pounds, and seconds again, medium difficulty. Parts origin location is indicated. So bottom center again. Given a lot of the same dimensions, it does make me want to try. No, I guess not. The without the clippy, the inside and the spring that actually closes on this geometry, the is not going to be the same geometry. So my first thought was to go back to 8.2 and copy that geometry, but I don't think that's really going to help me much. So bottom center line circles, center line sweeps, the extrude cuts on the side, and patterns of mirror. Okay, well, we'll see what we can potentially mirror. It depends on how we make these 100,000ths cuts along each side. So it could either be a sketch mirror or a feature mirror, depending on our choices. All right, so front plane sketch. We're not really given an isometric view, so, and they're not asking for center of mass. So I'm not too concerned, but I do want to make it, oh yeah, the isometric view sort of goes that way. Yeah. So when I'm looking at this, the front plane, the right plane is passing through, and we'll check those geometries. So we have 0.45. Let me fly it in one more time. 0.45 to the center of the radius, and then 1.75 to to their center. So that's telling me we got interior geometry and external. No, we got interior geometry, internal. The radius is pointed to that side. Okay. So we're pretty much drawing the inside, and then we'll come back to our geometry. So let's go arc and arc. And then there's a small line coming off tangent, but no, I don't want that to be vertical. And then we'll go continuous. And then there should be a continuous and another small line. All right, so let's get some dimensions on this and start bringing it in. So 0.35, and it scales 0.65, and we have, do we have an angle? No. All right, so for this, we'll do 0.45 plus 1.75, get the overall dimension. So just the way that moved, I can tell I didn't get a tangent there. And we didn't get a tangent there, so let's bring that back. All right, so if we go to the arcs and make them symmetric, select, control, select, control, select. Yeah, they're sort of moving that way. So the center points are moving. We're going to have the same endpoints probably because of the arc, but let's go ahead and make the endpoint symmetric to bring that back. Add a tangency. All right, so between the centers, so if we made that line a center and wherever that one lines up, then I'm thinking that we'll have a collinear. Okay, so in this case, I do have to select the two lines. And our dimension goes to the radius of 0.45. And just double checking my numbers. And a distance of 0.45 from the center. Okay, well that'll stretch things out a little bit. All right, so on the interior, that looks okay. 0.15 to the end. All right, so that one came back that way. So if we said that that was the center, I'm sure that'll make it complicated, but let's go ahead with it. .15, and then between the 2 points, we want to stay close so that we end up with the linear distance, 1.25. Okay, we'll see what that does. All right, on our right plane, we need to pick a point, and one of these I would like to do the plane at the end point. All right, so the easy way is to go into the right plane, draw the circle below it. The fun way, though, is to generate a plane with our reference geometry. So there are going to be times where just the geometry is going to be such that you're going to be better off picking the plane at a point. All right, so basically perpendicular, or in the case of a curve, tangent to the curve at a point, and be able to generate that geometry right at the end point. So we open up a sketch and we'll see how this goes. All right, so I lost my frame of reference, and we want to build this to the outside. So we're going to go horizontal, and then coincident to the circle, and we need a dimension. Our dimension then is 0.3. All right, let's go ahead and see what that looks like. All right, sketch 1. So we go into our profile, we go into our path, and then because it's at the end point, it's not asking me about directionality, so we can go ahead and accept. and then usually just hide the plane so that it is not in the mix. So the profile I'd actually like to be able to see, because its geometry is going to pick up some of that that shape. So I did 0.15 is from the base, so part of this, let's drag this in and take another look. So it's just 0.1 wide, and we need to figure out this arc. So the 0.15 from center and then out. So I'm not sure if I did that right, but it looks like our arc continues and then goes back to the face. So there's just a little bit there. So 1.25 to the center line. All right, gonna have to jump into that and kind of figure it out as I go, because I'm not quite sure what to do with that that geometry, since it's at the tip of the arc. So let's go into the front plane. And actually, that was to the center. So from that face to that face, yeah, it's a little confusing. So let's go ahead and we will put in our geometry, get the continuous arc to go. So the 1.25 actually ends up back there. Okay. So that line should be somewhere. May have to go back and do some calculation. Radius of 0.15, since it's going to, actually it should be fine on the tangency. What is the diameter of 1.15? Nope. Control Z, Control Z, Control Z. Let's go 0.15 on the diameter. And then let's see where this lands on our numbers. So 1.05. So if I push it back to the 1.25 to the center, well, then it's going to make those go away, because that is that line. So that makes sense. And we need that to be at least parallel or perpendicular. All right, so we got the fully defined sketch, but we're off by a little bit. So let's take a look at that sketch again. So 0.15. And we're looking for the distance from there to there. So that has a normal distance of 1.5. So that's pretty much going to eliminate that, that geometry. So let's edit the sketch. And if we can, we're going to change that to construction geometry, which is going to mess something else up, mainly that. So when we go back into the sketch, yeah, we know that there's some dangling dimensions. The best way to treat dangling dimensions is to go to display delete relations, identify the ones with the amber. Hope I'm still in. So since I got that out of the way, we get that out of the way. Let's go with the 1.25. Then we have that. And does it still follow the curvature? So got curvature going that way. So yeah, I think it does. So that being the case, we have the 1.5 or 0.15 plus the 0.15 that actually, let's go ahead and accept that because I'm not through messing it up. So really this needs to be 0.3 now that I'm seeing that geometry. And we switch it back to, and we'll continue and ignore because, oh, it didn't like that. Well, that's strange. Really shouldn't have cared. The swept operation failed to complete. So let's see what we did. Oh, the point, all right, so let's go back into that sketch because the 1.25 and the 0.3 is actually at the center. And let's see if we can drag that down. I've had pretty good luck so far. 1.25. All right, so be prepared if you're guessing like I am. You have to make the adjustments. So I need to remove material on that face, and this is going to get a little strange because I'll probably leave those two bodies if we make the cut from the outside. All right, well, let's give it a shot. I'm going to hide the profile again. And we still pretty much need to do the same thing on that side. And based on its profile, it's on the face. So sketch 3, we're going to go ahead and perform an extrude cut. And I'm going to offset it 50 thousandths. And this may be why they wanted to do the mirror. And if we reverse the offset and go up to next, then let's clear the sketch, and I want the contour so that it removes that material. And then I'm zero thickness geometry. Well, that's fun. All right, so when it creates we have a tangent C at this point. There's a 0 point that we're dealing with. So let's see, we have the 0.3, but that's not really, that is affecting that. So I either need to add a little more material or offset that face before I try to cut it. This would be a good time to show the direct editing. So under direct editing, we can move a face, and I just need to move the face enough. Let's see, is it going to let me go in that direction? We just want to do offset anyway. So yeah, 30 thousandths is plenty. We're going to leave a body when a solid body when we make that cut. So I just need something to either make it a little bit bigger or a little bit smaller so that it has that offset. All right, 0.05. Let's reverse it, go up to next, and then hit OK. Up, and I wanted to remove the whole thing. So that sort of did what I want, except it's still attached. So that's interesting. Always fun. Oh, now I needed to be in the feature. So this one actually is a pretty good challenge. I know I'm making it more complicated than it probably needs to be. So when we pick the outside, that's going to remove all of that material. So we had that stop. Yeah. Okay, so I'm going to back up a few steps and rethink. I would think my original, now if this is exam, this is exactly what I don't want to happen is the second guessing and the changing of strategies. But the 0.3 does work. We stopped there. The curvature was my issue with that one in making that that cut. All right, so yeah, I do need that curvature. All right, otherwise this doesn't follow all the way around. All right, well, let's try the another tactic. Let's go center line, coordinate. We'll see if we can find a midpoint. Okay, it will allow me to do that vertical. Nope, it's still wanting to do a midpoint, which is fine. I really just need it to go from there to there. And then we need to mirror that. Okay, which one was, oh. Okay, let's make sure I'm in the mirror about. Okay, now I've got my preview. It all looks pretty good. And once we add the dimension, 0.1, then we're going to extrude cut up to vertex to that point. Okay, so that being the case, I think that offset probably would still help because on my region I would want to do all of that. All right, let's see what we can cut with sketch 3 then, because I think it's still going to give me that 0 point. Well, we'll go ahead and add it in. So the move face, then the sketch, we're going to go back into the extrude cut, and we need to pick our regions. It's going to be through all both. Clear the selection because I want the circle, and it's not really giving me anything there. All right, I was hoping I could get both of those in the same mix. So let's go back into sketch 3. All right, so sketch 3 doesn't have that geometry yet. And I'm just going to create a tool to overrun this since, yeah, this ran a little bit more than what I was expecting on figuring out those endpoints. All right, and then it doesn't matter how long because I just need that region to make the cut. All right, now when we do the we've got that cut. All right, we need sketch 3, extrude cut, and then we're going to pick the region, and we end up with that weird looking thing. All right, so sure there's an easy way, but the first time you go through, boy, that's I'm not really seeing that that geometry. So this should go a little bit easier. In fact, we could probably convert our rectangles from the previous, but yeah, I've already made it complicated enough. So let's go with that. and that for the coincident, and then that for the tangent. I'll make sure to mirror that. Go to the 100,000ths. And then we're going to extrude it back to the face. So we don't really have a vertex there. So let's go back to sketch 1 and show it so that we can use that sketch as our vertex. Extrude cut up to vertex. And no, there is not a direction 2, and we go ahead and accept it. All right, I think we can hide sketch 1 and go ahead and save this. P8-4. All right, our size then, see how close we got after all of that, is volume of 0.51 cubic inches. Evaluate mass properties and 0.151 cubic inches. So definitely interesting geometry on that one.